Well, the communication factor is going to become huge in how we decide to do our operations. Right now, with the Earth right there, I mean, communications are instantaneous. And actually, the space station was designed to be operated in an environment where communications are instantaneous. For example, you have a lot of specialists on the ground who help for the space station and the shuttle both, actually. There's a lot of specialists on the ground who have the knowledge in their heads about how to maintain the systems on board. And we're trained more as technicians on the space station because we have a group of engineers always in mission control supporting us when we're digging into a system and, you know, clipping wires and changing plumbing and all these things that you have to do to maintain some of the systems. When you start having time delays of 8 minutes, 10 minutes, or, you know, pick your time, that becomes a very impractical operational model. And so the whole fundamental way we design hardware has to change when we go somewhere like Mars. And not just because of communications, but also because of logistics. For example, you have to optimize the space system, not for each subsystem, but for the whole integrated system. For example, you want to have common fans, you want to have common avionics boxes, you want to have common plugs and outlets. So that means that if you size a fan for optimizing the cooling across the whole, all of the subsystems, that means it's going to be probably too big for some, because you're going to have to size it for the smallest throughput of air in the very smallest avionics or the largest avionics box. So we're going to have to design things differently, and we're going to have to train the crews differently. We're going to have to train them really more as plumbers, electricians, and repairmen, where we have a set of blueprints. We can dig into the system with a set of blueprints, and we can do what's necessary without requiring a whole group of engineers on the ground in mission control, because it's not practical when you have huge time delays to have that kind of interaction. So the operations and the center of operations is going to have to shift tactically from the ground to the crew. And the ground will have to be limited to strategic planning and long-term kinds of work, where the crew will have to be more and more in charge of the day and deciding how to tackle these things, because you can't have, for a long duration mission, a team on the ground supporting in the same manner that we do for the space station. But it starts with the design of the spacecraft. We couldn't do that with station right now because the spacecraft design for the ISS does not support that kind of operation. We have to have the engineers, because all of the systems on the space station are so highly specialized and so very unique that it would be impractical as a crew to get the blueprints out and trace lines at the level that you need to do. So the system we design for Mars and the Moon needs to be much more simplistic, much more common, and much more keyed to the operator being able to just pick up a stack of blueprints and do what they need to do.